for the price-demand equation, x equals f of p equals the square root of 56.25 minus 9p, question 10 asks us to determine the price interval over which raising the price will increase revenue and the interval over which price increase will decrease revenue. And to do that, we need to determine the elasticity of demand function and use it to find those intervals. So because 56.25 minus 9p is under a radical, then we know that the price p cannot be greater than $6.25, because that will make this radicand, which is the expression for, or which is the term for an expression under a radical, that will make this radicand negative, and we can't take the square root of a negative. So $6.25 is the maximum price for this particular price-demand equation. So to find the elasticity, we're going to need the derivative of f of p, this function here. And to find that derivative, we really are going to be, the best way to do that is to write this 56.25 minus 9p raised to the half. We write that radical with the rational exponent so that it's 56.25 minus 9p raised to the half. And then when we take the derivative of that, we're going to use the power rule, and so that 1/2 comes around front, and we subtract 1 from this exponent, and a half minus 1 is negative 1/2. Then we take the derivative of the inside, so we're using the chain rule, and so the derivative of this inner portion is negative 9, and then that gets multiplied onto the end. Now when we have a fraction in the numerator, that's the same thing as multiplying the fraction times, or this fraction times the entire larger fraction. That means the 1 is multiplied times the numerator, and the 2 is multiplied times the denominator. So using this in our formula, we have negative, formula for elasticity is negative p, and there's the p, and there's the negative, times this derivative, 1/2 times the quantity 56.25 minus 9p raised to the negative 1/2 times the negative 9. And then in the denominator we just have the function square root of 56.25 minus 9p, and I've written it again here in this denominator. I've written it with this rational exponent. Excuse me. Well, because this expression has a negative exponent, that means that we can bring the expression down to the denominator and make the exponent positive. And of course, as I said, the 2 is in the denominator here, and the negative 9 times the negative in front of the of the fraction makes this a positive 9. And then in the denominator we have 56.25 minus 9p raised to the half multiplied by 56.25 minus 9p raised to the half. So that's multiplying two square roots together. And when you multiply square roots of the same expression together, then those square roots cancel, and what you have left is the radicand, which is, as I said, the expression for what's inside the radical, raised to the first power. Then 56.25 is divisible by 9, And so you factor a 9 out of this 56.25 minus 9p, and so we'll have that 9 here, and we have the 9 in the numerator, and those two cancel, and that leaves p over 2 times 6.25 minus p, and here I've distributed that, and so 2 times 6.25 is 12.5, and 2 times negative p is negative 2p. And so that is our elasticity of demand function, and we need to set that equal, right here, we need to set that equal to 1 to find the price that gives us unit elasticity, because when the elasticity of demand is equal to 1, that price is the price at which we have unit elasticity. So that's very easy to do. It's just a linear function. We multiply both sides of the equation by 12.5 minus 2p, and that leaves us with p equals 12.5 minus 2p. We add 2p to both sides, and so we have 3p equals 12.5. Then we divide both sides of this equation by 3, and that leaves us a single p here, and 12.5 divided by 3 is approximately $4.17. So 4.16666, not terminating or repeating, or perpetually repeating, actually. 4.1666, which we round up to 4.17. Well, a price below 417 is going to give us an elasticity of demand. It's less than 1 but greater than 0, and so on the interval 0 to 417 our elasticity of demand is inelastic. It's inelastic, and inelastic means that when you increase the price, the revenue increases. Now beyond $4.17, but not going any farther than $6.25, because that's our maximum price. Between $4.17 and $6.25, demand is elastic, and that means that if we increase price, then we'll actually decrease revenue. So we've used elasticity to answer the question. And notice that at the point of $4.17, we have strict inequality here and here, because we can't include $4.17. That is that's the price at which we have unit elasticity.